So I believe this is recording. Here in each of these, they give us two functions and they ask us to determine if these two functions are inverses of each other. So in each case, we want to find the function compositions, f composed with g and g composed with f, and compare them and see if they both equal x, then we'll conclude that the two functions are inverses. If they don't equal x, then we'll conclude they're not. So if we jump in on this first one, and we find the function composition f composed with g. That is that g is the input of f, and we see that g is a linear function. This 4x is a line that passes through the origin with a slope of 4. And what does f always do to the input? F always creates a multiplication problem where the first factor is negative 1/4 and the second factor is our input. So if we multiply these two factors together here, this simplifies to the opposite of x. And since that's not equal to x, I know that these two functions are not inverses of each other. But let's go ahead, in case someone had found g composed with f, illustrate that this is not going to equal x either. At least most of the time it won't. Sometimes there may be situations where it will. All right, so f is the line that's passing through the origin with a slope of negative 1/4. G always creates a multiplication problem where it's 4 times the input. And this product is the opposite of x. So again, since that's not equal to x, we conclude that these are not inverses of each other. All right. In this middle one, we want to do the same thing. If we find f composed with g, if g is the input of f, g is this ratio that is, I think that's a 5x minus 2. I suppose it could say 3x minus 2, but I think it says 5x minus 2. I'm sure your eyes are better than mine. All right, so what does f do to this input? F always creates a ratio. Negative 2 is always in the numerator. The denominator is always the input minus 5. And for us, this input is this 5x minus 2 over x. So we want to try to simplify this. So within that denominator, I see a fraction, and within that fraction, I see a denominator of x. So that's where I'm going to start. I'm going to multiply this ratio by the number 1, but I'm going to write 1 as x divided by x. And the reason I'm choosing that is because of this denominator. It's easy to multiply fractions together. You multiply straight across the numerator and straight across in the denominator. So in the numerator, I have negative 2 times x. And in this denominator, I've got this binomial, these two terms. This first term, 5x minus 2 over x, it gets multiplied by x. And this second term, this 5, it gets multiplied by x. So now I simplify this. So in the denominator, this first term, these x's cancel, and we have 5x minus 2. And then we have minus 5x. Well, you can see what happens now. The 5x minus 5x, those like terms, cancel each other out. So in the denominator, we're left with this fraction negative 2x in the numerator. These terms cancel, and negative 2 in the denominator. Negative 2 divided by negative 2 is positive 1, so this reduces to x. So it's very likely that these two functions are inverses of each other, but we do have to do the composition the other way. The definition requires it. So here f is the input of g, and f is the ratio negative 2 divided by x minus 5. And what g will always do to the input is create a ratio where the numerator is 5 times that input minus 2, and the denominator is always the input. So here we have negative 2 over x minus 5, and here we have negative 2 over x minus 5. So we can rewrite this division, this complex fraction. We can rewrite this fraction bar as a division symbol. So in the numerator, we have 5 times negative 2 over x minus 5 minus 2. That's my numerator, and that is being divided by this denominator of negative 2 over x minus 5. And if I change this division to multiplication, then I have to take the reciprocal of that divisor. Division is the same thing as multiplying by the reciprocal. So I have this 5 times negative 2 over x minus 5 minus 2, and that's being multiplied now by x minus 5 divided by negative 2. So don't make any silly mistakes in simplifying this, which may be easy. You really got to focus and make sure that you write things out clearly and that you think about what you're doing. So in this binomial, this first term is getting pretty complicated now, because within that first term, I now have 3 factors. I have 5 times negative 2 over x minus 5, and it gets multiplied by this x minus 5 over negative 2. And in this second term, this 2, it gets multiplied by this factor x minus 5 over negative 2. That's what it is to distribute this multiplication over this subtraction. Both of these terms get multiplied by that factor. Well, things kind of start to begin to clean up kind of nice because we have a lot of common factors here. Since these two factors are inverses of each other, you can see their product is just the number 1. So these 3 factors all multiply together to give us 5. And then in this second factor over here, or excuse me, second term, I want to be careful here. So I'm going to change this to addition and make this addition of the opposite. And now this negative 2 divided by negative 2 cancel. So I have an addition symbol here. And this, we're adding this numerator, x minus 5. And you can see the 5 minus 5 cancels, and we have x. So we conclude that these are inverses of each other. and you could rename one of them. You could rename G as F inverse, or you could rename G as F inverse, or F as G inverse. All right, so let's do this last one. So it's the same idea that we've been doing for all of these problems, and that's to find F composed with G and G composed with F. So if we find this composition, we're using these two functions F and G to build a new function. And if this new function is the identity function, if it equals X, then we know these two functions are inverses of each other. So G is this linear function that is 1/5 x plus 1. And what does F always do to the input? F always creates a subtraction problem where it takes 5 times the input and then it subtracts 5. Well, here our input is 1/5 x plus 1. So this multiplication distributes over the addition. Both of these terms get multiplied by 5. When I multiply this first term, the 5 and 1/5 are reciprocals of each other, and they just have a product of 1, so I get 1x. When I multiply the second term, 1 is the multiplicative identity. When you multiply by 1, you get the identical thing back. So 5 times 1 is 5. And these are additive inverses. They add up to 0, and we get x. So it's very likely that these two functions are inverses of each other. The definition requires that we find the other composition. All right, so f is this linear function 5x minus 5. And what does g do to the input? G always creates an addition problem where the first term is 1/5 times the input, and the second term is always 1. So if we're taking 1/5 of this 5x minus 5, each of these terms gets multiplied by 1/5. So, and they're reciprocal. 1/5 and 5 are reciprocals of each other, and so we get 1x minus 1, and the minus 1 and plus 1 cancel each other out, and we get just x. So we conclude that these are inverses of each other. And you could rename F and call it G inverse. You could rename G and call it F inverse. I just say the same thing. You could rename each of these to indicate they're inverses of each other. I hope that helps, and I will talk to you later. Bye.